Hello and welcome to the SCC331 Smart Environment Toolkit, designed to allow end users to quickly and easily create and manage smart environments. In this video we will describe the features provided by the SET Toolkit.
The technician has his own credentials, which give him access to an administrator page where he is able to properly set up the SCT for users. He simply plugs in a base station for the user where they want their smart environment setting up. The engineer can then assign that base station to the user from the administrator area of the website. The Smart Environment Toolkit uses Java sunspots designed by Oracle. Sunspots are distributed, embedded sensor devices that can be used to track data, detect events, and provide smart information about any environment. One base station can talk to multiple sunspots, and users can easily add sunspots to their SCT. Adding a new spot to the system is as simple as turning the spot on, and the system will automatically detect it. To claim a spot, the user simply logs into the system with their credentials and sees that the system has detected their spot. And adds the spot by inputting the spot's unique address code into the system. The user gets notified when they have successfully added a new spot.
Users can set up new zones in their smart environment from the Configure Zones page. As you can see, adding a new zone immediately starts the necessary services on the sunspot required to track the heat and light in the zone. You can tell these services have started because of the LEDs turning on the sunspot. Users can resize their created zones to their liking. In this example, we're adding 3 zones to represent the 3 zones in our lab: North, Center and South. And as you can see, the users can resize the zones to their liking.
We split the lab up into 3 zones: North Zone, Center Zone and South Zone.
The brightness of a zone is shown in real time by changing the color of each zone.
We also monitored light and heat data, visualizing this data in real time and storing it on our remote database. Making use of the radio transmitters on those Java sunspots, we were able to provide a means of tracking the users across zones.
Heat and light data can be compared across days so that it can be easily reviewed and analysed. Using the live data, such as light data, we are able to control actuators in the lab. We also enabled manual control over the actuators.
We can track a door by adding a job to the spot device and specifying the compass as the sensor, as well as the appropriate threshold that you can find out simply by playing around with it during your spare time. Then we can attach the spot device that has the compass sensor to the door, and when we open the door we can see the results showing up on our website. Here you can see that the fridge door open event is logged in real time. As well as zones, you can add objects to the SCT map. Here is an example of adding a fridge door monitor object to the SCT map. When events occur on the SCT map, the object flashes to show this. Moving to the actuators. Firstly, you simply need to plug it in, and then connect any USB device to it that you would need. We're using a noise generating device in this example. Then on the website, you only have to enter its 5-symbol ID, and when it's added, just give it some name and specify what is it going to be triggered by. Afterwards, you may specify time range restriction for the trigger, so for example, it won't go off when you're sleeping. And now we are going to add the condition when the actuator should change its state. We specify an event which is going to be monitored. If the value of the monitored object becomes more than our threshold, and it stays on that level for some time, then the actuator will be triggered. As a result, if we open the fridge door and keep it open for a while, it will trigger our actuator, which has a sound alarm device connected to it. As soon as the fridge door closes, the actuator gets triggered again and the alarm goes away. Same scenario could be applied to an entrance door. The door gets open and the alarm goes off.
Using the accelerometer on the sunspot, we are also able to track the water level in a cup. Using Twitter, our system broadcasts hourly updates on the heat and light data of the lab. Our system also responds to tweets by other Twitter users.
Additionally to the website means of viewing the data, we have an Android application that currently has some part of that functionality. You just need to input the same credentials to log in as you would do on the website, and afterwards you're presented with the data. You can see who is in the zone, what objects and actuators are there. When you choose either a user or an object, graphs will be presented with the available data, where you can zoom in and scroll. For the actuators, you are able to control their current state setting, choosing to be in either auto or on and off for manual control. And if there is more than one zone created, then those are going to be presented in the drop-down menu list. In case you wish to switch to another user or simply to log off, you can use the respective button. Thank you for watching and stay tuned.